All right, so let's do these notes. Hopefully you have the reactions physical / chemical notes page in front of you. So if you look at it, there is like a thought bubble where it says properties of matter, and then there's the line that's physical can be blank without. That's what we're going to start at. So this screen is for that first section. So the properties of matter with the physical stuff. So the physical can be described without changing the object. So the things that go in that line, describe, change. So physical properties can be described without changing the matter or the object. And then our examples, so you have the EX for examples. If you look at the white box on the screen, our examples are things like size, density, mass, the freezing point, the boiling point, viscosity, like how stretchy is it, volume, how much space does it take up, the color of it, flexibility, and permeability. So permeability is can liquids or air, can stuff pass through it pretty easily. So I need you to pick 2. 3 would be better, but 2 is minimum. Pick 2 and write those down. Chemical properties. So chemical properties observe during a chemical reaction. So I have to put it through some kind of test to see if it's a chemical property or if it's just a regular physical property. So chemical properties, I have to observe them through a chemical reaction. In my examples, you're going to pick 2. Remember, 3 is better, but 2 will work. Flammability, so will it catch fire? Oxidation state, will it react to the oxygen in the atmosphere? Toxicity, is it poisonous? Reactivity to water, what's it going to do when I put it in water? Radioactivity, so how is it going to give off excess ions and be some kind of dangerous to organic materials? And then chemical stability, so flammability, oxidation state, toxicity, reactivity with water, radioactivity, chemical stability. You're going to pick 2. 3 is better, but you need to pick 2. Write them down where it says examples. And then we're going to look at the part that says indicators of a physical change. So while you're finishing your thoughts, so the objects. So if you look around your desk or around the room, the physical property of your desk, right, your place that you're sitting at. Most of them, the tabletops, are brown, they're hard, they're kind of a rectangular square shape, they're fairly smooth. Some of them may have scratches on them. You could measure it and figure out the size of it. So is it 36 inches across? Is it 25 inches across? Is it 56 inches across? So those are all of our physical properties we could observe. Our chemical properties, so this just goes a little bit deeper. Our chemical properties, remember, they're properties that I can only observe if I put it through some kind of chemical reaction test. So if I'm looking at these objects, 3 ways I could test like a banana. I can put the banana out, I can leave it out and watch it start to turn brown. That's its oxidation state. If I put it on heat and I like put it over a fire and watch and see if it's going to catch fire or is it just going to kind of melt. When I put them through the test for their chemical properties, these are chemical changes that I can't undo. I can't kind of like scratch it off and make it new again. So these are typically permanent, and they're creating a new property. So let's look at our indicators of a chemical or physical change. So on your notes, it says physical changes that blank make a blank blank. So physical changes. A change that doesn't make a new substance. Changes that doesn't or do not make or result a new substance. So our biggest one is our state of matter change. Did it go from a solid to a liquid? Did it go from a gas to a solid? It's going to look the same, or it's not going to look the same, but it's still the same stuff. So the pictures that are here on the slide. The top one is a tea set that somebody has broken and then put back into art. So the tea set, it's still cups, it's still saucers, You can still tell it's made out of porcelain or glass, but it doesn't look the same. So I can't use them the same way as I did before. And then the bottom picture is another piece of art, but it's meant to look like a melted ice cream truck. So if you've ever gotten ice cream from the grocery store and you bring it home, when you bring it home, if you don't put it up right away, it kind of starts to do that melty thing. I can put it back in the refrigerator and refreeze it. Same thing with like butter. If I leave butter out too long on the countertop, it can start to be very liquidy, but when I put it back in the refrigerator, it re-solidifies. So our physical change examples. You have space for some examples. Our examples, remember, you need at least 2. They start fourth one down. So if you break a bottle, it's still glass. If you paint your fingernails, it's not going to stop them from being fingernails. Some common examples of a physical change are melting, freezing, condensing, breaking, crushing, cutting, and bending. So anytime it does a state of matter change, it's going to be a physical change. So then let's look at one of the things that gets argued quite a bit. If I cut my hair, when I cut my hair, it's still hair. I can't glue it back to my head and make it grow. It's going to keep growing. So physical changes most of the time can be reversed or are not permanent. So let's do chemical properties. So your chemical properties, these are things that make a new substance. Make a new substance. It's typically going to add heat. So I'm adding heat. Or fire. So I'll go on my lines there. So I'll pull this slide up. Changes that make another substance or new substance, adding heat or fire. And I get new properties. That's the biggest one. They're new properties. So if I look at the pictures, fireworks, that's a big one. I can't unfirework the fireworks. Once they explode and they do their kabooms and their pows, it is what it is. So they look really pretty for a couple seconds, and then that's it. I can't rewind it. Our examples or our indicators of a chemical change. So you have this kind of written down there for you. So where it has the big P, and then it says precipitate. Above the word precipitate, you're going to write the word please. So our acronym, our mnemonic device for remembering chemical changes are please, excuse, coughs, burps, and sneezes. So that's what goes with those letters. So please is to precipitate. I get a new substance. So 2 liquids making a solid and a liquid making a gas. So a precipitate is a new substance. The E for excuse is also energy. So if I have a release of light or heat, so if there's fire or bright lights, glow sticks would fall under this category. The C is for color or coughs, right? So coughs goes first, and then next to the little line or in the line goes color. So color change, I get a new color, and that's not like when Miss Carter puts purple on her hair. That's like when I bleach the hair would give it a new color, or when it starts to mold, or the penny turns kind of that reddish blue color from the rust. B is going to be burps, and then in the line the word bubbles. So when I have a gas release, so when there's fizzy things happening. And then S is for sneezes or smells, and I have an odor change. So please excuse coughs, burps, sneezes, or precipitate, energy, color, bubbles, and smells. So you may need to pause it so you can get all those written down. And there's a video, so you're going to do a video review, and then we're going to do the chart together. So I'm going to put the link in the announcement for the video, but I'm going to skip the video because otherwise we'll be here forever. So then the chart. So the First one is the milk and the soap. So if you've ever seen this example, when I touch the milk, there's some food coloring in it, but when I touch the surface of the milk with that soap on the Q-tip, it makes that kind of spirally pattern. So I can't unhook the fat proteins. So is that going to be a physical or a chemical? It's going to be a chemical reaction because I get new properties, new substances. The sawing of the wood, is that going to be a physical or chemical property change? It's going to be a physical change because it's still wood, it just looks different. A broken bone, physical or chemical reaction? It's going to be a physical because it's still a bone, now it's just broken. And then the last one is the yellow liquid that's made from the combination of the two clear liquids. That's going to be a chemical, and that's my precipitate. So you have a chart that's on the bottom of your notes there. Physical changes are, chemical changes are. You're going to fill in the quick definition, and then you're going to answer the couple, 6 questions down there at the bottom. So lighting a match, ice melting, cutting paper, etc., etc. And then you're going to take a picture of the bottom section, and you're going to post it for your exit ticket for the day.